Unnormalized data anomalies. Unnormalized data refers to a database that hasn't undergone normalization, and therefore may contain data redundancy, inconsistency, and other issues. These issues are known as data anomalies, and they can cause significant problems in a database's operation and maintenance. There are three primary types of anomalies in unnormalized data.
1. Insertion anomaly. An insertion anomaly occurs when the database schema forces you to insert redundant data, or prevents you from inserting data at all due to the absence of some other data.
Example: consider a table storing student information along with the courses they are enrolled in. Issue occur in the previous table. If a new course is introduced but no students have enrolled in it yet, you might be forced to insert a null value for studented and student name, or you might not be able to insert the course at all, so the impact of this could lead to incomplete or incorrect data in the database, making it difficult to maintain and query. 2. Update anomaly. An update anomaly occurs when changes to redundant data are not correctly propagated across the database, leading to inconsistencies. Example: continuing with the same table. Let us see the issue occur in the previous table. If Dr. Smith's name changes, you would need to update his name in every row where math is listed. If you miss any row, the database would have inconsistent data, so the impact of this can lead to errors when querying the database, as the data might show different information depending on where you look. 3. Deletion anomaly. A deletion anomaly occurs when deleting data inadvertently removes other valuable data that should not be lost. Example: using the same table, suppose a student graduates, and you delete their record. The main issue in the table is, if Charlie is the last student enrolled in math and you delete his record, you would also lose information about the course math and the instructor Dr. Smith, even though that information is still relevant. The impact of this can lead to the accidental loss of important data, which might be needed for other operations or historical reference. To summarize, unnormalized data can lead to significant challenges in database management, including insertion anomalies, difficulty in adding new data without redundancy, update anomalies, inconsistent data after updates, deletion anomalies, accidental loss of important data. So we conclude that normalization helps eliminate these anomalies by organizing the database into structured, interrelated tables, reducing redundancy, and maintaining data integrity. Answer with true or false. A deletion anomaly occurs when removing a record also deletes unintended data. The answer is true. Deletion anomalies can lead to unintended data loss. Describe a scenario where an insertion anomaly might occur in an unnormalized database. The answer is, in a table storing student courses, you might be forced to insert a course along with a student's data. If no students are enrolled in a new course, you might have to insert null or incorrect data. The answer is, in a table storing student courses, you might be forced to insert a course along with a student's data. If no students are enrolled in a new course, you might have to insert null or incorrect data. The answer is that, in a table where course details are stored with student enrollment, deleting the last student enrolled in a course might also delete the course details, even though the course still exists.